Okay, I record and share the screen. Okay, everyone can see my screen? Okay, so let me make it full. Okay, so today we will do the last portion. It's here for the virtual machine. So, some guys, it's 2 weeks from now, the final weeks. Yeah, the final exam week. So you still have 2, maybe 3. You should schedule a time with for 2 weeks. Then you should have last week to prepare your presentation, record your presentation. I think your presentation may not be, you just do once, maybe you need twice or third time, so you need more time to prepare your presentation. So that's why you should start now as early as possible, otherwise you may miss the deadline. Okay, for detail, you can you can check back the Blackboard the next week. So the next week there's no class, so I hope I finish the whole class by this week. So next week you will focus on your group project. Okay, let's go back for our schedule. So the virtual machine. So the virtual machine actually is the compiler. Actually, the compiler is the whole thing from here. So the compiler is from the high language to the assembly language. So all is the compiler. But last time we did discuss to say that, okay, if I do the compiler directly, I may have some problem. The problem is that I have so many high-level language and I have so many different platforms. If I do directly mapping, then I need m times n number of compilers. Because I have one language, then I need one assembly language, one high-level language. I need one compiler to do this. But this one takes too much time. It's not a good idea. So we separated 2 parts. One is we call the virtual machine translator. So virtual machine translator, this one is focused on from the virtual machine to assembly language. So you can you don't care too much about the high-level language. You just say, okay, if you give me the high-level language, can I transfer to the virtual machine language? And then this virtual machine language will go translate to the assembly language. So the virtual machine translator only focuses on what kind of assembly language it is. Then based on the different assembly language, then I have fixed virtual machine language. So I translate to the assembly language. Then compiler will do is compile your high-level language and check whether you have the mistake or warning something happens. And if everything is okay, then the compiler will compile it and create the intermediate language. This one is the virtual machine language. So last class, we have already do arithmetic commands analysis. So if I have the high-level language, then I convert to the virtual machine language. Then I do this one. How do we evaluate your arithmetic and Boolean commands? Then this one is the last lecture we do to say that we create a stack, right? So we have the stack and do the evaluation through the stack. So this stack evaluation, actually the idea is come from the data you have already learned in the data structure. I hope you have some homework assignment or some in-class preparation for the stack evaluation for no matter you do for arithmetic or for the Boolean commands. Then we have the memory access. If you want to to access the memory, to load from the memory, or you try to push into the, you try to load from memory means you push, or you do save to the memory, then this one you do the pop. This one is also, we can use the stack evaluation. So stack evaluation is the key functions or key data structure we use for not only commands evaluation, but also we do the memory access. So this is the brief summary for the last class, last week class. So today, our class is try to look at this chapter. We will do these two things. So one is a program flow commands. So program flow commands is actually you deal with if-else statement, as well as you deal with, if-else is easy, so you deal with the loop. So how do we deal with the loop? And then the next two classes, so Wednesday and Friday, we focus on the last thing, which is most important and headache thing, is called function calling commands. So for our high level language, we create functions to perform certain amount of work instead of you do the assembly language. If you want to repeat, say that I want to do multiple multiplications, then I need to do one by one, just do copy and paste. So your code will be very long. But in our high level language, we can create a function to say, I call some function and to achieve certain kind of process. So this one is our function calling commands, but Wednesday and Friday. So this one we will do today, and this one we will do Wednesday. Probably we will also need Friday to finish the whole thing because it's a little bit complicated. So this is the schedule for this week. And when we finish this function calling commands, then we finish the whole class. So finish the whole new materials. Okay, so let us see some program structure. We base on our Jack machine. So it's quite similar to Java code or C++ code. So the only difference is we may need, we just create some kind of ugly things to tell the system whether you do the methods or you want to do the static variables, and this is the class, right? So what you will do is I have the class name, right? Then we have some variables, which is static, which is associated with the class, and we have certain kind of functions, we have certain kind of method, do something. Okay, so we have void function 1, void function 2. This one you have a function 3. So you can call it a method or you can call it a function, okay? So this one is same. And this is the source code look like. So we have methods and functions and associated with the variable list. This variable here is the static, which is a global inside the class. So look like your Java class, you define the variables at the beginning, and then inside the class, and then inside the method, you can create some local variables, right? This one we have already analyzed. Analyzed in the last week class. So today, what we will do is this source code. When it's compiled, it will have the virtual machine code. Then it all is associated with function 1 to function 3 with 4 class, and with bar class we have F1 and F2, 2 functions. Okay. Below it, I will do the virtual machine translator. So those functions associated with static. So if you declare as a static, it means that it's shared by all those functions. So F1, F2, F3 share the static. You will see that you will have the static sharing. And then you have the argument passing, you have the argument list. So each function, for example, F1 will have here, and F3 will have here. So they share the whole static, means you change any variable's value in the static part. For example, I change it in the method F1, it will affect function F3 because this is static. This is why we call it static. It's across multiple functions. But if I change the local variable for F1, even if you have the same variable name, it will not affect the local variable in F3. So because they separate, right? This one is separate. Okay, so the local argument, that pointer, this 5, it will be associated with particular function. Okay, we have the temp and the constant, which is also globally. And this global is even bigger than the static. Okay, static is associated with class. Okay, this one is associated with one virtual machine. And machine code, this one is another class. You will have another static variable. But if you create a temporary or you create a constant, it will share by the whole stuff. So means every virtual machine code will share the same thing. So one machine code change the constant, then it will also change it here. But usually if you declare like a constant, this one is not changed, right? So for example, our famous constant is pi, right? Pi 3.14 like that. This one is the constant you never change, right? You use it. But what you can change is the temp. So the temp portion, if you do the temp portion, you should be very, very careful. Okay. And then when I finish, then I have another translator to do. This translator will translate our virtual machine code, this code together with this assignment and create assembly code. Finally, you will have the machine language code. So any question about the structure of virtual machine? Okay, so let us move forward. So finally, if you finish your whole code, this whole code will be one file and running we call it, in the Java, you call it the binary code, right? Binary code. So, okay, so what is the challenge? Okay, let us see one examples like this. So this one is we do the square root, right? So we do, or we solve the problem for the quadratic function. So quadratic function, and then this is one root for that quadratic function. So this time I will say that, okay, if a is not equal to 0, then I will use this formula. And then if it's 0, then I will do this guy. Okay, so if else part, and I will do this guy. So let us see this portion of code, what we have. Okay, what we have already learned is this one. We know how to evaluate the Boolean function. We know how to do arithmetic for this guy, right? We can do 4 times A times C, no problem. 2 times A, no problem. Negative V, no problem. But we cannot do this portion. So I will change the color to see what we cannot do. So We cannot do power, right? We cannot do this. B to the power, B square actually, power B2, we cannot do. We cannot do so far is square root. We don't know how virtual machine can do associated with square root. But suppose I can do the function square root or I can do the function power. This one, if I have the solution for that one, I know how to do that. Then it looks like I can do the same as 4 times A times C, right? So the computer, previously in our hardware, no matter we build in hardware or we build in software, so we have the hardware portion or software portion to calculate the multiplication. But if we have the way to say that we can do the power, then we can treat like this is an option, right? This one is such easy, just use the function, and this function we treat like operation. So if I have, then it's okay. And what we are also missing is we cannot do if else statement, right? So this one is the program control we cannot do. We cannot do the things is the function, power and the square root. But what we can do, we can already do multiplication, divides, plus, minus, this kind of thing. We can do the evaluation of the Boolean function. So arithmetic operation, we have already know how to do that. Boolean operations, yes. Program flow. Today, we will do program flow. It's quite easy, just need 5 to 10 more minutes. We can finish this one. And then subroutines, we need 2 class to do that. Like the subroutine, like a square root, like power, we need extra work to deal with that. This extra work is not that easy, so we need effort. So all these abstraction are handled by the virtual machine level rather than the compiler. Okay, that's why in here I finished the whole thing. Then the compiler actually is not. We don't need to focus on that because this one has already moved at the virtual machine level. Okay, so now what we deal with our program. So the program flow is we have 3 things. One is called a label. This label usually let the program to go to that label. So I create the label. So this one, if I do the program flow commands, this one is create a label. Create a label. And this one is jump to the label. Jump to label. Okay, so right, this is jump to the label without checking any kind of Boolean expression. And if go to, so this one is I will check the Boolean expression and to see if it's not 0, then it's jump. If it's 0, then I will move to the next step. So let us see when we do the multiplication. So last class we do the multiplication. So we push. So if you forget, you can check the next class and you can check the previous class sample. So we have push pop. So we have 2 arguments, x and y. We have constant 0 and we have, I think we have 2 constant, 0 and 1. We have local variables. We have 2 local variables, if you still remember. So I will have the while loop. So while loop to say that if y equals to 0, then I will stop. Otherwise, I will keep adding x, y times, right? So this is the whole thing. So the code is look like that is the summation equals to 0, right? So summation equals to 0 while I will do I equals to y, y equals to y. So if I remember correctly, so I equals to y, and the summation equals to 0, while I equals, so if it's not equal to 0, so not equal to 0, not equal to 0. If I is not equal to 0, I will erase this. So while I not equal to 0, I will let the summation. So this is the code summation plus equals to x, right? So x. And let I decrease by 1. Okay, so this is the whole code. Right, so I will get y and add x y times if I not equal to 0, and every time I add x once, I will let I decrease by 1. So you can see that, okay, this is exactly the code. So where do I need to do create a label? These 2 lines, I don't need a label, because this is just goes to the variable. So this one I have push, pop, push, pop. So this one is, this 2 means summation equal to 0. This one is means I equal to y, right? I have pushed the argument 1 and pop to the I, right? So then I need to check whether the local variable is equal to 0 or not, right? So here I need to create the label, because I need to control it, right? So I need to control how many times I will add x, right? So this one, I will create the label. You will see that while loop is based on the label. And then inside is the condition checking, right? So I will check I and check the value between I and 0 if they are equal. If it's equal, if it's not 0, so if it's not 0, so I'm thinking this one is wrong. So if it's 0, then I will jump, right? So this one is not correct. So pop the topmost stack elements. So then if it's 0, then I will jump. So if they are equal, if they are equal, it's true. So sorry, this one is correct. How do I undo it? So whatever. So this one is correct because our assembly will say that if it's true, it will generate a -1. Otherwise, it will generate 0. So if it's true, this one, if it's true, it's a jump to make sure that a little bit crazy. So our assembly will say that if true, if it's true, it will be -1, right? It will be -1. Otherwise, it will be 0. So this time, if y is not I is not equal to 0, then it's false. So it will be 0. If it's 0, then I will go along to that one. When I finish the while loop, So this is inside the while loop, right? Your summation add x, and then this one is decrease by 1, so decrease by 1. And then I will go back to the loop, right? So then this is the condition checking. So I not equal to 0. So this whole thing forms a while loop. And then if it's I equal to 0, then it's true, so it's generate a -1. So it will go to the end portion. If it's the end portion, so it will give the results. Okay, so this is the whole procedure. If I meet the while loop, or if I give the if statement is quite easy. I just need to do the if condition and then go to certain place. If you have the while loop, then you will have something jump back where you start your loop. So this one is the whole thing when we deal with the program flow. So the loop, you will have the one thing go back. If you just do if statement, you will just use the if go to this commands. So this is the whole thing for the program. Yeah, that's good. It's just 10 minutes. And then my question is, if I have this guy, then how do I do to translate to assembly? Do we need some extra work? So like last time we do is, okay, we have this push and a pop, then we need extra work, right? So if you do this yes, then let me know what kind of extra work you need to do. If anyone think we need to do something else, then please let me know what is the other things I need to do. Because for previous, well, I would do push and pop, so we have a little bit extra work we need to do for assembly. Because we in assembly language, there's no push and pop, right? You need to translate to segments, which segment I will deal with. In here, for here, if we do this flow control, think about our assembly language. Our assembly language, we only need to say that, okay, this label loop, I just need to do is a loop, right? I create this guy, right? Instead of label loop, I will do loop in the assembly. If go to, how do I do? So equal, right? We have the equal. So I need to do is at a certain kind of end. So this one, I can directly say at end. At end, then I will say if this one, I push it back. So this one, this two line of code, I will just do at end. It say equal, right? J E Q, right? So I want to do is equal. So this one is you of course you need to push into some place, right? At some register. For example, you put into the D register, then I say D if it's equal. Okay. So there's not a lot of actual work need to do, but actual work is very limited. Actually, you can treat it like there's no actual work needed. So this one implementation is by translation to assembly. It's quite simple. Label declaration. We just need a loop here, right? And the go-to directive can be effected directly by assembly commands, because this one, if go to end, then right, it means at end I will do equal or 0 j equal, right? So this one is the way we can translate our program flow commands directly to the assembly language. If this is true, so it's quite easy. It's not like push and pop. So it's well, we are happy to do that. So this one is quite simple. So any question? Okay, if there's no questions, that's all for today's class. And stop sharing.